Okay, so imagine an AI that's so small it could literally fit on your phone, but it's powerful enough to go head-to-head with giants like Google's Gemini Pro. Well, that's not science fiction anymore. That's exactly what Samsung just dropped with its new breakthrough, TRM, the Tiny Recursive Model. We're talking a 7 million parameter AI that's flipping the script on everything we thought we knew about intelligence. It's hinting that maybe, just maybe, it's not about how big your AI is, but how smart it thinks. So that leads us to the big question, right? The real David versus Goliath story for our time. Can an AI that's the size of a simple phone app actually outthink a machine that needs an entire room and a massive power grid? Well, you might want to buckle up because the answer is pretty wild. All right, let's break this down. On one side of the ring, you've got the heavyweights, the reigning champs. We're talking models like GPT-4 and Gemini. These things have billions, sometimes trillions of parameters. You can think of parameters as like little knobs the AI uses to learn things. The more knobs, the more complex it can get, but it also means they are unbelievably power hungry. And then in the other corner, you've got Samsung's TRM. Just 7 million parameters. It was built for one thing, efficiency. I mean, the difference in scale is just, it's hard to even wrap your head around, which makes what it can do so mind-blowing. Now, to really get why TRM is such a game changer, we first have to talk about the current state of play. And that brings us to Section 1, the problem with big AI. For the past few years, the whole AI race has been running on one simple, powerful idea. Bigger is always better. You've seen it, right? Companies like OpenAI, Google, Anthropic, they've all been locked in this arms race to build bigger and bigger models. More GPUs, more data, and most importantly, more parameters. The whole philosophy was that if you just keep making it bigger, it'll eventually get smarter. But here's the catch, and it's a big one. This bigger is better approach has some serious downsides. These huge models, they cost a fortune to train and run. They can be kind of slow to respond. Their energy use is becoming a real environmental concern. And you literally need a supercomputer just to make one of them work. Samsung looked at all these problems and basically said, you know what? Let's try something completely different. So if just throwing more power at the problem isn't the answer, what is? Well, that's where the underdog's secret weapon comes in. Let's jump into Section 2 and look at how TRM thinks recursively. This, right here, is the magic trick. It's a concept called recursive refinement. So instead of just spitting out an answer on the first try and hoping it's right, TRM works in a loop. It actually rethinks its own logic over and over again, making its answer better with each pass. It's a lot like how you might write a rough draft, then read it back, see the mistakes, and fix them to make it better. Here's how it works in practice. First, TRM gets a problem, say a really tough puzzle. It comes up with a first draft of the answer. But then, and this is the key part, it uses its own internal thinking space to check its work. If it spots a flaw in its own logic, it goes back to the drawing board and refines the answer. It keeps doing this loop again and again until it's actually confident that it has the best solution. So what's really happening here is you can almost picture the AI looking at its own answer and having this little moment where it thinks, hang on, I can do better than this, and then it actually does. That's the secret sauce. That's the fundamental logic that makes this little model punch so far above its weight. Okay, that all sounds really cool in theory, right? But does it actually work in the real world? Well, let's get to the numbers. It's time for Section 3, the surprising benchmark results. When the research paper for this thing dropped, it seriously sent shock waves through the AI world. The performance of this tiny model wasn't just pretty good. In a lot of cases, it was flat out better than its giant competitors. The results were just stunning. And hey, the numbers don't lie. Take a look at a benchmark called Sudoku Extreme. It's designed to test pure, hardcore logical reasoning. TRM scored an insane 87.4%, which blew past models hundreds of times bigger. Then there's the ARC AGI benchmark. It's one of the toughest tests for abstract problem solving out there, and it even beat Google's Gemini Pro in several areas. And these aren't just little party tricks. These are major signs of some seriously advanced reasoning. Okay, let's just stop and think about this for a second. Let this number really sink in. This tiny model, the one that pulled off those world-class results, is less than 1/100% the size of a model like GPT-4. That's like a pocket calculator outthinking a supercomputer, not by being bigger, but by thinking smarter. So we've seen how it works, we've seen the incredible results, but what's the big picture here? What does this all mean for the future? let's get into our final section, what this means for AI. All right, let's be real for a minute. TRM is not a ChatGPT killer. At least not yet. Its real strength is in very structured, logic-based tasks, things like puzzles and abstract reasoning. It's not built for just shooting the breeze in an open conversation. And yeah, while its reasoning is amazing for its size, it's still a very long way from true human-level general intelligence. But what's so incredibly exciting is the door this opens. TRM could be the pioneer for a whole new kind of AI, models that are small, private, and efficient enough to run right there on our devices. Imagine your phone not just taking commands, but actually reasoning through a problem for you, all without ever needing to ping a massive server farm in the cloud. And that leaves us with this huge, fascinating question about where all this is heading. Is the future of AI going to be controlled by a few giant, all-powerful superbrains living in the cloud? Or is intelligence about to become decentralized, with small, powerful, and efficient AI thinking for itself, right on the devices we carry around every single day? Samsung's Tiny Giant is suggesting the next big thing in AI might actually be something very, very small.